In this tutorial, I will show you how to create a map for the navigation to stack using the SLAM toolbox package. For this, we are going to use a simulation of a robot, the Turtlebot 3, but the steps that we will do here and that are related to SLAM can be replicated for any robot as long as you have a LiDAR publishing on a scan topic. And let's get started. And first, we are going to make sure that we have everything correctly installed and set up. So I'm using ROS2 Humble here on Ubuntu 22.04, and so make sure that you have installed ROS2. And also, if I go to my bash rc file, so bash rc here, in my home directory, you should have this source/opt/ros/ the name of the distribution, and then setup.bash. You can see I have commented this here. What is that? Is that, well, we will also here change the DDS implementation for ROS2, okay? So I'm not gonna go into much details about DDS, but basically you can change the DDS, and the default one is called fast DDS as I record the video, but there are some issues with fast DDS and the navigation to stack. And so it was recommended to use Cyclone DDS instead. So let's actually install, so I'm just gonna close this. And to install Cyclone DDS, you will do sudo apt install ROS dash and then the name of the distribution, which is Humble for me, and then rmw, which means ROS middleware, and then dash Cyclone DDS dash cpp. So you install this package, which was, well, I already installed before. And then once you have this package installed, you can go back to your bash rc and you will add this line here, export, and then rmw_implementation, so all uppercase. And so you export this environment variable with rmw cyclone DDS cpp using also underscore here. So which means that, so I'm going to save this. When I open a new terminal, this is going to use Cyclone DDS instead. Okay, now let's make sure that we have the navigation to stack installed. So we can install with sudo apt install ROS dash distribution here. And then we have navigation to. So that's the first package we're going to install. And then ROS dash humble dash nav2 dash bring up. Okay, we need to install those two packages. And for the demo that we are going to do, we also need to install Turtlebot 3. So I'm going to do ROS dash humble Turtlebot 3, and I'm going to put a star to install all packages related to Turtlebot 3. Okay, so let's install this. And well, I've already done that before as well. So that can be quite a lot of packages. You just wait a bit. And then once you have this, you can install the SLAM toolbox as well, which is an additional package to install. And so with sudo apt install ROS dash distribution dash SLAM dash toolbox, just like that. And well, already installed as well because I've done it before. Okay, so once you have done all the steps, ROS2 is correctly installed, configured, and you have also installed the navigation to Turtlebot 3 and the SLAM toolbox. Now we can start our robot. Okay, so this part is the part that is specific to the robot. So if you have another robot, then you will need to start your robot. So basically start the stack of your robot. And here I'm just going to use Turtlebot 3 for this example. And to use Turtlebot 3, we first need to export an environment variable to tell which robot we want to use, so which variation of the robot. So that's also super specific to Turtlebot 3. And for this, I'm going to open my bash rc again. That's going to be easier. And I'm just going to put, so it doesn't really matter where, but I'm going to put here export. And then Turtlebot 3 underscore model, just like that, is equal to, and I'm going to put waffle. So there is the burger model and there is the waffle model. And by doing this, by exporting this environment variable, I'm just saying that I want to use the waffle every time. Okay, so it's just going to be easier like that. I export the environment variable here. I can just now create, open a new terminal, and everything is going to work. And here I'm going to make it as for terminal. Okay, so I have this. And I'm going to start the Turtlebot 3 robot in Gazebo. So to do that, I have a package, so ROS2 launch. I have a package named turtlebot3_gazebo, and then I can choose different worlds, and I'm gonna just choose turtlebot3 world.launch.py. Okay, that's the basic one. And you should see this, so it might take some time. If you have never launched turtlebot3 in this world, it might take some time. You may have this orange pop-up here with a loading message or something like that, and just wait for at least a few minutes. Okay, even if it's 5 minutes, just wait until you get to this, and then the second time that you will launch, it will be much faster. Okay, so we have the robot, and you can see that's the most important thing that we need for the SLAM toolbox to actually work, is we have this LiDAR, okay? So you need the LiDAR that's gonna publish on a scan topic to make sure that the SLAM toolbox can actually work. And well, let's make sure of that. If I do a ROS2 topic list, do I have a scan topic? Yes, I have a scan topic. Okay, and this scan topic, if I do ROS2 topic info scan, it is a laser scan message, okay, from the sensor message package, right? So if you don't have this, then well, you need to make sure that you have that for your robot. And if the scan is named something else, you can just remap the topic when you start the launch file. Okay, no problem with that. Okay, so that's basically the requirement so that you can use SLAM toolbox. So you run your robot, whatever robot that you have, you make sure that you have a scan topic with a laser scan message type. And now, well, so we keep this robot here. Okay, the robot is still running. I'm gonna start the SLAM toolbox here. And actually, I don't start the SLAM toolbox. I need first to start the navigation stack. Okay, let's do clear here. And I will do ROS2 launch with nav2 bring up, and then navigation launch.py. Okay, so you can see the syntax is exactly this, nav2 bring up, and then navigation_launch.py. And one thing I'm gonna add, and that's if you are using Gazebo, use sim time is equal to true, okay? Because when we run Gazebo, we are using simulation time, so you want to use basically the time that's being simulated inside Gazebo. If you are not using Gazebo, then you don't use the use sim time. Okay, I will launch this, and let's wait a bit. Okay, so you can see it's starting. We have the planner server, smooth. Well, we have controller server, a lot of things, and well, nothing else is happening. We just have basically started the navigation 2, but nothing else is happening. So once we have on the terminal 1, we have the robot. On the terminal 2, we have the navigation stack. On the terminal 3, I'm going to start the SLAM toolbox. And how to start the SLAM toolbox? You can do ROS2 launch SLAM toolbox like this. And then we have online async. So you can use the auto completion here. Online async launch.py. That's the one we will need. And so you can run this command, and if you are using Gazebo, you also put use sim time is equal to true. Okay, so I run this command, and well, SLAM toolbox is started. You can see we have stuff happening here. Okay, and well, still nothing else because well, we haven't started any graphical tools such as RVs, and so that's what we're gonna do here. We're gonna start RVs. Note that if you start RVs, so you can start RVs just like that with no config. Let's start with RVs2, and RVs is here. Well, you will start with nothing, and you will have to configure stuff by yourself, but we can already start with an existing configuration. I'm going to do ROS2 run RVs2 and then RVs2, so that's the same thing as the previous command. And then to start from a default configuration, you can add a -d. I'm going to put this a bit bigger. -d, and then the path to the configuration you want to use. And so here, there's actually an already existing configuration in the nav2 bring-up package. So how to go to the nav2 bring-up package? Well, you go to where ROS2 is installed. So /opt/ROS/humble here, because I'm using humble. And then you will have a share. So you need to go in the share directory. That's where all the launch files and all the configuration files are installed. And once you are in this share folder, then you can go to the nav2 bring-up. And then we will have, it's called an RVs folder. And then we have something like default let's press tab twice. We have nav2 default view .rvs. Okay, so you run this, and then you can press enter. And I'm gonna put RVs here, and you can see now, well, it's much better. We have a lot of stuff already, maybe even too much. So I'm just gonna remove the global planner. I'm gonna remove controller. Okay, I'm gonna keep the TF, I'm gonna keep the map and the laser scan. So we have, you can see, we have the robot here. That's the robot that we have right there in Gazebo. And this robot starts to map. Okay, so with the existing data points, so here you can see the red points are the data points for the laser scan. Then we start to make the map. And so any point that is in white here is considered as free space, and points that are in black are obstacles. So now all we need to do is to make the robot move inside this environment so that we can create the map. And once we have a map that looks correct, then we can save this map. So let's make the robot move. And to make the robot move, well, here it's also specific to your own robot. Maybe you have a teleop keyboard node, maybe you have a joystick, maybe, well, you must have something to control the robot. And here for the Turtlebot 3, we have actually a node called, so I will need to open a new terminal. We just open quickly a terminal here. And I will do ROS2 run Turtlebot 3 teleop and then teleop keyboard. Okay, and you can see you have the keys here with W, A, S, D, X. You can make the robot move around. And so you can give I'm pressing W here, and you can see the robot starts to move forward. Okay, and when it moves on Gazebo, on RVs, I can see that the robot is also moving. So TFs are actually moving, and the map will start to, you can see the map starts to be generated. So let's go a bit faster here. We can make the robot turn a bit, and to the right, to the left, but usually is better for the generation of the map. Okay, press S to stop. And then, well, let's just go to the left a bit, and let's finish the map. I'm not gonna finish with all the pixels. Okay, if I miss a few pixels, it's gonna be fine. And let's try not to bump into obstacles. So you can see I can watch the robot directly, but I can also check what's happening on RVs. Although if you are working with a real robot, I encourage you to actually check the real robot and not just RVs, okay? Because RVs is basically what ROS thinks the robot is doing. But maybe there is a difference with the reality, so you might actually want to check exactly what's happening in your real world. Okay, and now I have a map that looks like it's correct. Okay, so I can actually save this map. Okay, so what I can do is I can stop my teleop, but make sure you don't stop any of those. Okay, you can see here I have the robot, I have the navigation tool, I have the SLAM toolbox, and I have RVs. So make sure you keep those running, okay, and you don't stop those before you have saved the map. And to save the map, let's do a clear here. To save the map, so we are in our home directory. Okay, I'm here and I can save the map with ROS2 run nav2 map server, and then we have map saver CLI. Okay, so that's the node that will take the map here that's generated and save it. And I can add -F to provide the file name that I want. Let's call it my map. Here I don't put any extension. Okay, the extensions are going to be handled by the node. So I just press enter and you should see something like this. If it doesn't work, if you have some errors in red, maybe just start again. Okay, sometimes it happens and you just do it a few times and it should work in the end. And now what I have is I have my map.yaml and my map.pgm. Let's actually check here. You can see I have information about the map in a YAML format, and I have the map that we have generated. You can see that's an image with pixels, with white pixels, gray pixels, and black pixels. Great, and with this generated map, now you are ready to make the robot navigate with the Nav2 stack. And if you want to go further from here, check out my Nav2 course, which contains more than 6 hours of video content, including practice activities. If you are still relatively new to the Nav2 stack, this course will give you a great understanding of the stack and will make you progress much faster. Alright, thank you for watching and maybe see you in the course or in the next tutorial.